We're going to talk about line spectra with the purpose of understanding atomic structure. Now, when light passes through a prism, then on the other side of the prism, you will see all of the colors of a rainbow, and they will appear in a continuous spectrum. Now, what this means is that each element is going to have a unique line spectrum. So, what is a line spectrum? Here are some different examples of line spectrum. Now, when the light emitted by excited atoms passes through a prism, then we get these different line spectra. In the first one, we have the line spectrum of sodium. Now, depending on your eyes, you might see one line, you might see two, three, four, or even five. There is one line down here, two here, one up here, and finally one here. Sometimes people will see more right here. It just depends on your eyes and the different wavelengths you can see. Now, the reason we have these different spectra is due to electrons. Now, electrons exist naturally in what is called the ground state. So the ground state is going to be that lowest possible energy level for an atom's electrons, so where they naturally occur. Now, if you put some energy into that electron, it's going to go up into an excited state. So the electron is going to get excited and it's going to go up into a different energy level. So here we have an electron in the ground state energy level, and here our energy is going up. If we absorb energy into that electron, it can get excited into a different energy level. Now, it can't stay there indefinitely. If you take that energy away, it's no longer excited. It's going to release energy as it decays back down or it relaxes back down. And as it does so, it's going to give off a different type of energy that was absorbed. So electrons will always return to the ground state. And as it does that, it's going to release energy in the form of a photon. And a photon is a particle of light. So the energy that is absorbed by that ground state electron to get excited up, it's going to push it up. And as it comes back down, it's going to give off a different energy. Now, if the electron gets excited up to a different energy level, it's going to give off a different photon. So that's why in these line spectra, we see all these different lines because those are the different electrons relaxing back down to the ground state from the different energy levels. And this is actually how a laser works. And laser, believe it or not, is actually an acronym. So whenever you write laser, it should be written like this. And it stands for light because energy is light. This is the absorbed energy here is in the form of light. This is light amplification by stimulated. And that is because we are exciting that electron, we're stimulating it up into that excited state by stimulated emission. Emission is a fancy word for giving off of radiation. Now, radiation is the process of that electron going back down. So when this electron goes back down and it releases that energy, that is radiation. So laser is light amplification by stimulated emission of radiation.